Okay, I think we're live. I'm not sure, let me just check. Yeah, nice. That's amazing. Yeah, the resolution should be 1080. Okay, I'll close. Yeah, this, I think. Cool. Yeah, I haven't. Yesterday there was a comment on the channel and it said like um, log back into the channel and post a new video. So here I am. I decided to stream something a little bit different. Something a little bit different. I will tell you guys everything about it. I will just need to check some things. Okay, so let me just close off some things that we won't need. Okay, let's close this off. Okay. Can someone in the chat, if there's someone in the chat, can you just write to see, like, probably the audio is not that great because I'm using another microphone. This is not my usual microphone, so I would guess that there should be I hope I can get the other microphone to get it working, but essentially this is what is going to be for today. Let's see what is going on here. The current bitrate is lower than what is recommended. Yes, I'm using a bit lower the bitrate is a bit lower than usual, just because the internet connection is just very slow here. When I'm in Slovenia, the internet connection, yeah, I have a really great internet connection there, but here it's a bit slower, so I will just keep that bitrate down. So okay, let's okay, so let's move on. And what are we going to be working to today is on the FFLib. I'm doing this project for so this project is for my master's, but essentially the air conditioning unit, I'll leave it a little bit now just to get it warm. So this project is for my master's, but we are doing this as an open source project. Everyone can collaborate on this here. So let me show you what we have here. We are using the thing is, it's going to be a little bit laggy maybe, but and let me see, I hope you guys can see this. I will just zoom in and show you other stuff as well. Okay, yeah, today we're going to be coding in Python, but what you see, I don't like how OBS downscale stuff, because this is a 4K monitor and you have to downscale you have to downscale to 1080p just to stream it. But essentially, yeah, so today we're going to be coding in Python, but as you know, I like C++ more. So next stream is going to be something to do with C++. So either developing our what I'm working on actually is developing a node engine, or maybe just maybe converting my rendering engine from direct 2D to OpenGL. That could be fun as well. Other stuff could include some C++ projects that I have in mind. So some projects that that I have in mind are something to do with the Macedonian language. So that could be some stuff that we could be working on. But okay, so let's not get into that more. The FFLib you can just show you. Let me see here. Okay. GitHub. Yes, I'm logged in. So the FFLib is a library. It's a library for the forward algorithm. And this library is essentially based on PyTorch, but it implements for now two different networks. Today we're going to implement a third, the most complicated neural network on the forward algorithm that was proposed. So this is the FFRNN, the recurrent neural network. This library, what is really cool about how I set it up, this library, is the dependencies are very like just these three dependencies: PyTorch, Torch Vision, and TQDM. But it has MyPy, Black, and PyTest. So MyPy is like strictly with strict checking. So type checking, if you didn't know, Python actually allows you to specify types. So it could be a typed language, even though it's not by default a typed language. MyPy allows you to specify what are the types. So this is like self layers is a list of FF layers, and this FF layers is just a Python module, a PyTorch module that is a class essentially, right? So what is cool about this project? It uses this MyPy for type checking. So it checks, and it is really annoying sometimes because you have to really get your types down correctly. If you don't get it, there will be warnings and errors. Then there's Black, which is a formatter. It even if you like make a little mistake of like some like white space there or here, it will just make it real nice formatted. And then there's this PyTest, which just this library for testing unit tests in Python. The library here we're developing is based on the forward algorithm. We will be talking about the forward algorithm a lot on this channel from now on, because this is my master's thesis, and also this is something that I have been working on for quite some time now. And it was originally there's if you go GitHub, so let me just maybe on YouTube, if I can do this. How can I do this? On the is it possible edit description? Okay, so I will put it in the description. Yeah, I will put it in the description. So yes, the library itself, the forward algorithm, it's another way of teaching neural networks essentially, and it's not by back propagation, but just like teaching each layer separately. And it was proposed by Jeffrey Hinton one something maybe even 2 years ago. I don't quite remember. See the paper. The paper is 2022, so December 2022, so 2 years, 2 and something. And the algorithm is essentially easy to implement, but there's no library implementing this algorithm nowhere. And what is really difficult, it is that you have to have a library that implements this stuff, because it's implementing by hand. It's very tedious, and one mistake can get you throwing your head against the wall, right? So it's quite quite and it's not nothing is documented in the when Jeffrey proposed this idea. He just wrote this paper, but there was not much documentation how things are supposed to be. Okay, so the library is based here. There's these interfaces, and then there's this these layers, and we are just going to go. Excuse me. We're just going to go and open up. There's this research that I was doing, and yeah, I think I don't need that. I can have this RNN. So there's this stash that I have already moved here. There are these files here now. FFC, I will delete this because I have already implemented this. Recurrent layer and FFRNN. This is today what we're going to be porting over to the library. So the FF recurrent layer is essentially everything is here pretty much written. Let me just maybe zoom in one more. I don't know, like next time, maybe it's better just to downscale. Maybe next time we'll be using some other, or maybe I can just do here output. I don't know how to tell OBS to, yeah, you see, like there's like this bicubic subsampling, and can I actually magnify or use magnify? Yeah, this is very laggy. Oh, no, I'm not gonna use magnifier. Yeah, the problem is this OBS downsampling. This is a bicubic, so sharpened scaling, but maybe there's something a little bit better. And there's 1080p, just the resolution that I have to from 4K to 1080p downsample. Okay, so let's FFRNN, recurrent layer. How did I read? Yeah, recurrent layer. Okay. Yeah, you see, there are some, like this is the amount of features on the forward direction, this is on the recurrent direction, this is on the backward direction. We are going, okay, this is naming convention is fine. Loss function, did we implement a loss function here? No, the loss function is this. So the activation function is a module. Loss, yeah, what is a loss function here? Loss function, let me just see in the linear layer. There's no loss function. There's loss threshold, but loss function is already defined. So yeah, we're not gonna have a loss function. Loss threshold is this, it's a float. There's the learning rate, there's what index is this layer at. I don't know if we need actually that for do we need index? So the thing is, when you're engineering something like this library, you have to think in the future, right? So here I was engineering that when you forward something, you're forwarding a list of tensors, and then you're just taking a look at what I want really from this list, which could be really nice actually. Incredibly nice, but in once, okay, so what do I want? I want the last one and this and this, so I want 3 of things. So if it's 3 of things, I can just do h previous, which is a torch tensor, h recurrent, which is again a torch tensor, and h next, which is again a torch tensor. So why I don't want lists to is because there's no concrete stuff. If you're using this library, there's nothing concrete that it will tell you how the library manages this list inside, and this is much more concrete here. I don't know if I want to clone and detach these tensors. Okay, so first of all, we won't want index here. You have an activation function, which is a real by default. Either you're maximizing or minimizing the loss. Interesting. Now here, let's say here, yeah, you have this minimize. Okay, so minimize beta, you have some parameter. Now this callable stuff has to have, because it's strict, it will have this, and yeah, typing, yeah, okay. And then the device has to also have types, which is any or none. Okay, cool. Yeah, pretty much that's it from the constructor point of view. Now there's the loss threshold, activation, maximization, and beta. Yeah, this layer is on top of the PyTorch module, which means that all of these parameters that we're specifying here as a neural network parameter, it can be accessed through the module itself. And this is nice. This is nice because you can iterate the parameters, and this actually allows you to pickle stuff. So this serialization and serialization of the modules are already implemented because these parameters are here as parameters. Okay, we have some bias, we have an optimizer. Now the optimizer, yeah, now set up, now here set up the optimizer is better. So parameters, initialize parameters. Now initializing the parameters here is a little bit, here I don't know what should we expect here. For me it's very hard to code just with one function in the view. Maybe one day I can just make like a, that would be actually interesting to make a like a window that will follow the cursor, and that it will show you somewhere here like on the side where like it zoomed in, and then that way I can just see the whole thing without. Yeah, that could be actually something interesting to try in C or C++. Okay, so now here the reset parameters, I'm gonna leave that the reset parameters here, although I won't think that there will be reset parameters function. H previous, H next. So I will just a little bit work H recurrent, because the whole idea is that maybe it's better to do some example test here before we're changing everything from the ground up. But I think it's going to be cool. Okay, run train. Run training is there's H positive, H negative, and you're pushing the H positive and H negative, and then what you're doing here, you're getting from these H activations, you're pushing the vectors here, and then you're getting some. So these are not H. This is like I don't know how I named these here. In the FFnet there's like X. Maybe it's better just to name them X previous, X next, and yeah. Then you're multiplying, and then you're doing activation function. But here you take this thing, which is positive, which is a list of tensors. This is the last thing from this, and then you're pushing, but this is in one recurrent network. So you're not supposed to take this. You're supposed to. This is in one layer. How do you actually access this? Pretty interesting. Or maybe the train accepts this list and accepts where this layer is, and then it just. Yeah, this could be interesting. So what if I do like format here? Yeah, okay, so cool. This could be interesting. Index. So like I'm taking the index, which is an int, and then I'm saying, okay, the goodness function will be like a forward. Okay, let me see here. I had a goodness function which accepted a tensor, a logistic function, and is it an inverse or not, and then it did something here. Since this is going to be our goodness function in the other module as well, I'm trying to see if I could extend the FF linear to an FF recurrent, but no, extending this will make us that this is actually from a linear layer. No, I don't want this to be a linear layer. I will just copy this. Okay, this is a static function, isn't it? This is a static function. Yeah, it's a static function if there's like this forward thing, if I'm just yeah, if I provide this forward thing here, but it will be hard to type this because there's like an arguments here and there. No, it will be hard to type this. Yeah, so I will have a goodness function on the recurrent layer, which will take into it will take again these three H pref, H recurrent, and H next tensors, right? We'll take a logistic function, we'll take an inverse, and then it will just return. What does it return? It returns goodness function and all of no, forward function doesn't return the layers itself, right? It just returns this thing here. But yeah, the logistic function again returns what we want. Yeah, so it's okay. Yes, okay, goodness. It will return a tuple where G is the goodness, why is this thing on the server forward? And yeah, now instead of doing detach and cloning here, I will just assume that you have cloned and detached it, because I don't want to be detaching it in the in this here. Yeah, so you're assuming that essentially you have done this, and then h recurrent, h next. Since recurrent is in the middle, it does make sense. Zelda forward, it accepts these three things and returns a value. Okay, so now I can just do this. Since forwarding something, I don't think I should be able to detach. Okay, and then there's this x recurrent, and this is not normalized. I don't know why I chose the current not to be normalized. We maybe have to check this. So this is here, it's like normalization. You are multiplying, this is you're multiplying the weights, multiply the weights and the features in the forward and backward direction, and then this is the main equation, which I have to reference this in like a LaTeX. Thank you Ivan for the support. I'm in Strumica right now as well. Let me just put that here. Yeah, so I actually follow as well. I mean, I always follow Mendo and stuff like that, but I actually forgot to, you know what, I forgot to check about, so when is the when is the national competition? It's the 22nd. 22nd is a national competition. Cool. On the regional competitions, there were very nice success. I haven't had time to check the tasks. On the school competitions, I went to solve the tasks. They were nice, but I just didn't see the memory limit on the third problem, and on the last problem, I would think I would have gotten below time limit, but the problem was the again memory on the memory was just 64 megabytes on the last problem. So yeah, kind of small. I know that all of one solution, that solution, I know it now, but I'm just too lazy to write the solutions. I wrote n log n solution there. Okay, so there's, okay, so h pos, h negative, we accept these things. Now they're not called h, they will be called x's, and the thing is that since we accept index, we know that h pos at index is index -1 is like the previous layer. X pos index is the recurrent, and x pos index +1 is the next layer. So we're taking from all of these three layers, where we say the goodness function of all of these, and after that we essentially get the goodness positive and the y positive at once. I don't think we need actually the y positive, I'm not sure right now, but this is as well for the negative, so I can just probably do this. But the whole thing, oh, what? Isn't it just in selection does that? How do you find in selection? Oh, yeah, so this is the positive, and now since we have this, the goodness function here will be just a combination of these two goodness functions, but I don't quite remember how I wrote this. So the FFnet itself, no, not the FFnet, the FFlinear layer takes these goodness functions, it just takes the mean as this, and then that's it. And since we have to, yeah, okay, so that's simple. That's just simple. Takes just like concatenates both of these and takes the mean on that, and you have zero gradient. You just clear out the gradients and then you push backward pass. You have to ignore the type here because essentially backward is very like, this is why I don't like PyTorch is like, I love PyTorch, but these huge open source projects are really hard to maintain, and they're lacking some things like type types here, and it would have been really nice to have these types here. Just this is like just a boolean or non-probably type retain graph. This is boolean type. This is some inputs, which is like some lists, and but they don't care about types, so they just skip it. And after that, it just doesn't work with MyPy. Yeah, that's the whole problem here. Okay, so the recurrent layer looks good. This looks good. Since we don't need these, I'm just going to do that. So to dump them. Reset perimeter, set LR. Now, since recurrent neural, yeah, FFlinear is just a linear layer. It doesn't have a lot of stuff here except set LR, so there's no need to do actual interfacing with that. Yeah, okay. So recurrent layer, okay, works, should work, right? This now here everything is changed. Now we don't have a logger yet on the library, so there will be some things here. Okay, so let's first what I want is I want just to format this document just to be sure. Okay, this looks good. This here is from what is this now? FFLib and FF recurrent layer, import the recurrent layer. Now the dimensions. Okay, so the FFRNN is just since I don't like importing everything as NN, but I want to from torch NN import module. Okay. The FFRNN will be an example of how a 404 recurrent neural network works. So it shouldn't support everything that a FFRNN should support. It just a model for how an FFRNN should work. Activation .fn is a module. FF loss function. So for those, so what I maybe what I want to show you guys is just how I have the examples set up. So the examples, what is really interesting, what you can do is, like in Python, because it's an interpreted language, you can set up the examples as being as a file, but add these comments here, like with the 2% signs, and then then this makes it like in a block. So if I want to execute this whole block, I will just shift enter, do shift enter, and then it just connects to my Python environment. It imports this, and oh, it takes some time because Torch is a huge dependency, but it should import everything like this, and then you're moving on the next block and saying, okay, please set me up MNIST. Okay, MNIST is set up now, these layers. Okay, set me up these layers, and setting up the neural network, and just it's very easy, just your FF linear layers, set it up, and then you are setting up a probe here, try all classes, setting up test suite, which is a class in itself, and then you can start training this network. And now let's just train it for 2 epochs, just for an example, and it just trains it for 2 epochs. Here it reports some accuracy, how accurate did it get on the epochs. Of course, 2 epochs is just not enough, just 25% accuracy, which is not enough, but it's not random. 10% is random here because we have 10 classes. So it's better than random, but okay, 2 epochs, like in 60 epochs, it will be like 99 point something percent. Then you are running a test procedure, and the test procedure just calls this test suite.test, and it just tests everything inside of that stuff. And you are just doing okay, if you want to save the model, you just save it and exit, or you want just to load some pre-trained model, which you can do from like right here, test, and then like load this. And now, yeah, now test doesn't take okay, this is a fix that we should push. Okay, so yeah, 98.23% accuracy on the MNIST. This is a simple network, but yeah, so okay, so let's just push this. I mean, this fix, we should add this fix. Okay, let's discard this. Let's unstage this. Okay, this is the fix. Remove. I don't know, in the other network, do we have the same problem? No, the other network we don't have. Remove MNIST as parameter to the test procedure from examples. Okay, at the end, when we'll push everything on GitHub, there is a GitHub workflow which tests the type correctness and everything on GitHub, and just tells you if something is wrong. So, and yeah, of course, we would want to add some linear some test unit tests as well, because I don't have many unit tests. But let's first implement this recurrent neural network here. So the recurrent, okay, so the recurrent neural network, okay, the recurrent layer is implemented, but okay, let's just close this interactive thing. The RNN on the other side is a lot more complicated, because this contains many of these layers. Yeah, so this is a little bit more complicated here. Okay, so loss function, again, a loss function, we don't have a loss function. Loss threshold optimizer, the optimizer we set, it accepts anything and just returns any. So just, and the optimizer, we could just do Atom by default, but we'll see. LR, K-train, K-test low, and K-test is maybe K-test high. here. Not sure how to name this stuff. K-train is like how many iterations do you have for the training session, and then K-test low and K-test higher, from how many iterations should we accept, and this is how many is the maximum iterations. We'll write this, yeah. It's an unusual network. It actually, if I show you a diagram of this network, it is very, very unusual and very interesting neural network. It is unlike any other neural network you've seen in your life. Let me show you a diagram. Yeah, this. So this is a let me open this diagram in something better. Again, black, but whatever. Yeah, like you can see this. So this is like the input and this is the output, right? So the recurrent neural, this type of recurrent neural network, because every layer is essentially learning its own, it has weights from the layer previous, from the layer next, and from the same layer, it's from the layer itself. But this is in time 0, and then there's time 1, and then there's time 2, and then there's time 3. And then what it does, this layer, the layer 2, learns, given this output and these activations of these two layers, so these two vectors, it learns whether or not he likes this as good, something, or bad. It just does that. It learns if it's good or bad. And it's essentially very simple. VS Code is for noobs. You don't have the hardware to even care about this. Can you train your own model? The answer is no. Your GPU. Well, we're training actually toy models here. So this is totally different stuff from the AI models that you know, like the LLMs and the CNNs and whatever. This is state-of-the-art research on the on the 404. So there's no correlation. We're not training here. We're not training models to be perfect at something. We're training models just to see if they even work on these kind of new training algorithms. So this is something that we're just experimenting with. Just it's a recreational coding thing. So nothing too special. You know, it's just. Yes, I mean GPU poor. We're all GPU poor. We're not Elon Musk to have billions of. Python is actually everybody uses Python because it's very simple. It is just a wrapper for C, for the C++ library, the PyTorch. So if you just look at PyTorch, it just calls C functions. So essentially, you're not doing anything in Python. You're doing everything in C, and that is why it is performant. You have other wrappers for PyTorch, I think, as well. I'm not sure in what languages you have wrappers for PyTorch wrappers, but at the end of the day you're using C and C++. There are probably wrappers for PyTorch in other. I mean, it's just what was the PyTorch C++ API? This is their library for the foundational tensor mathematical operation library. C++ front end, C++ extensions. So essentially, like this A10 is in C or C++, I think. I'm not sure. A10 library. I think it's in. What is this? No. What is this? It's in C++, bro. Yeah. It uses CUDA, so it has to be in C++. Agentic transpilation is quickly changing the game. We can do JavaScript, C++ assembly bindings for. Okay, like I mean, you of course you can do whatever you want. Like it's there's not. I don't quite like Python, to be honest. I would prefer the library to be in C or C++. I mean C++, but the whole idea is it will be more maintainable in Python, because nobody actually, just on AI research, nobody does C++ work. It's painful, and there's just no way. Just we can argue all day long that in C++ it will be better, but how many people will work on this library if it's in C++, and how many will work on if it's Python, right? So it's just end of argument here. There's no even though I don't like Python. But you do not have hard to compete. How I don't compete. This library is not for competition. This is just to have fun with the 404 algorithm. There's no competition here. Like, I mean, this is just something new. I want to show you guys that this idea of taking vectors from next layers and from previous layers as well. This is nothing like if you have a backpropagation algorithm, you cannot do that, because this way it will be you cannot backpropagate through all of these things like that. It just won't work. And maybe with some, I don't know, maybe with some, but essentially again you're doing this forward way. So you should pick the best model and API to use instead of trying to compete. No, I mean I'm not trying to compete. No, why competing? It's just there's nothing to compete here. There's just it's based on PyTorch. There's no competition here. It's just we have fun. We are just coding a forward based recurrent neural network. Yeah, that's correct. I mean, yeah, I mean you have to have a lot of this, a lot of power for. But again, we don't care about that. We just care to have fun. Example wrapper of how 144 based recurrent neural network should be structured. Since FFRNN uses weights in the backward flow direction. Now I don't know how I'm supposed to call this backward flow direction, but because there's two directions. There's one direction where you have like there's X and Y direction, and then there's like you don't know how to name these directions. I'm from Macedonia, but I'm living in Slovenia mainly for studies and work. I work there. So let's see. Backward flow direction in order to set. No, okay. So backward. How do you name this? I don't know how do they name this stuff. Flow direction, because there's like one direction where you have this let me show you this one direction from left to right is a time dimension, and then there's like dimension where the layers flow from 0 to whatever layer you have. And this idea of you're having the layer dimension, and the time dimension just makes it real complicated to understand this kind of architecture. I don't know how to name this direction. Okay, let's see. Okay, so since the FFRNN uses weights in the backward direction in order to set all the layers appropriately, the FFRNN wrapper requires a list of all dimensions of all of the individual dense layers. Well, what we can do is the next idea. We can, since each layer has this notion of how much is like the recurrent features and how much are the backward and forward features. What we can do is we can actually just give this these layers. What I did is I initialized the layers inside the constructor of the FFRNN, which is not ideal, but it's very simple. It's very simple for new and it's very simple for experiments as well. But it's not ideal. Let me see. It's not ideal because somehow maybe something will change this. What if FFRNN is just given as interesting? Because dimensions here, it like everything is set up internally. Maybe a static function that will set up these layers for you, and then it will just call. You just call this static function, but no, I don't like this. I don't see what else would you do if you want to. If you want to access these layers, you have to go and access these layers. Self.layers. So since all of these dimensions use the American models for distillation, train synthetic. I just no, we're not. We're making our own library that has nothing to do with LLMs or models or anything. Like these are completely new models here, completely different architectures. So what are we doing here? If we are doing list of hints, no, I don't like this because PyTorch. PyTorch is very fun because it has this sequential thing, man. And this sequential PyTorch, this function, sequential, it allows you to map all of these layers like this. And all of these layers, since like you're mapping them in some kind of an order dictionary or whatever, you're just mapping them. It allows you to do things that, but since this is not a sequential network, this is a recurrent network, and it has various of structures. There's no way to map this. Yeah, I will, for now, what I'll do is I'll leave this dimension because it's easy to use. But afterwards, I would want to inject here, instead of having dimensions, if we have something like, okay, so maybe like this, maybe like this. Yeah, like this. So you're doing either a list of int or a list of FFRNNs. Can we do this? A list of int or a list of FFRNNs? Or maybe just do a double overrider constructor. Yeah, that could be nice as well. Yeah, let's do that. So let's do like one constructor which has this thing here, which has like layers, and it's a list of recurrent neural layers, but also this constructor where you have dimensions. So in the dimension constructor, you're just giving a list and it creates layers and it calls this constructor. Yeah, this could be cool. Cursor ID with class would already be steamrolling these lines. Yeah, I do have also GitHub Copilot and or whatever. You can just do anything with this, but no, I want just to call this because coding is just having fun, and I don't like ChatGPT. I don't like any of these LLMs. I just want to do my way. And yeah, maybe it's slow, maybe it's not, but fuck it, that's it, I'm doing my way. I have been coding for more than 10 years, so I'm 23 years. I have coded from 13 years, maybe less, maybe 10 years have started coding. And back in my day when we started coding Visual Basic, there were no AI tools, there were no AI things. So like, yeah, so I don't need AI to tell me what to do. No, it's not. I mean, no, it's not about beating. Why beating? No, we're not gonna beat anybody. We're just having fun. Activation function. Okay, so activation. Okay, what do we need for the layers? For the layers, we're just going to be copying this here. Okay, since everything here is like inside these layers, so I can just call in this initialization function. But what I want to do is I don't want to make it this. I want to have it in this. Just do this initialization. Since we want this loop to be from it's from 0. What is the first layer? The first layer is just I don't want this. Yeah, but then I see. Then you have to yeah, I'm gonna have an auxiliary layer here. So I'll have just like this, something like this, and then layers and this. And since we append this thing, and this could be sure. A loss function. Okay, what is the recurrent neural net? Now the recurrent layer takes other types of arguments which I need to provide. Yeah, nice for you. That's amazing. 29 years. That's amazing. Loss function self. Okay, self dot thresholds, LR activation function, maximization, beta optimizer, and device. Okay, cool. Now this works. Now we can just call this with our should we make another wrapper here. What else? If I'm providing the layers, then I don't need any activation function. I don't need any loss threshold. I don't need an optimizer, since this is all inside the layers. I need a learning rate. I need this stuff because this stuff is not given to the layers. This is all network related stuff. Maximization is given to the layers. And if all of the layers take into maximum. Okay, we need to check if all of the layers are maximizing stuff. Because if some layer is not maximizing stuff, then the network doesn't know that, so it has to be checked. This has to be checked. Okay, so if it has to be checked, then okay, we have to check this. Check if all layers have the same maximize. Beta could be different on all layers, doesn't matter. So yeah, so this is actually layer based stuff. So maybe layer based stuff would want to go here. This could be nice. So you're making this is all network based, this is all layer based. And the device itself just doesn't, device is not important. No, any or none. Okay, activation function is a module and it doesn't have a default parameter. Yeah, okay. Since maximization is network based, let them do this. Yeah, okay. So this looks good. This looks good. Now can you, okay, so since we have these layers, we are going, you can do, I'm trying to learn how to help the other countries beat the Americans. You can do GPU and sample optimization, train off synthetic data. This is gonna be, yeah, but why do, no, Americans are not the first in this thing right now. I mean AI, like, are they the first? I don't know. I mean, DeepSeek is not bad. I don't know, for me it's like every LLM model just sucks. It's very good for some things and sucks in others. So it's just, Americans need to justify this ridiculous spending on AI hardware. The small engineer can do optimizations to win. This is true. This is true. This is true, but they can do they see just this path is easier. You make more hardware, you build bigger models, and you get more. And if there's correlation, then there is just more. They will spend more. So this is just easier for them to do, and they will do it. Until they will just hit some plateau, and you'll see that there's nothing. Let me just check. Let's just check if, like, what was this? I'll check it later, maybe. Self.layers, okay, and then there's these things here where now all of these things are network related. Network related stuff. Test high. I should explain these things. Did I explain these things? Upbound frame taken into account in the testing phase, yes. Yeah, okay. But does your country have the AI hardware? No, of course not. I mean, no, my country doesn't even train AI. Not even like even Slovenia, for example, which is much better country. We rarely train AI. We do train some other, but the whole thing is like, if you have profit, you're training AI for profit. You're not training AI just to give it to the people and like they to have fun with ChatGPT. You know, you're training hardware for the military, for some profit, for detecting stuff, and LLMs suck at that stuff. They're too big, too expensive, too big to maintain, and we're still using other means of, so convolutional neural networks and other stuff are still very much popular, and all already pre-trained models, of course. I mean, I won't go on that. Everybody's reading the data. The loss function is I Okay, that's cool. Now create activations, create initial activations, the function create. So this guy should call can we? No, we can't have two in. I don't think Python supports overloads, does it? But what we can do is we can have all of these does Python support overload? I'm not a Python programmer. Python need overload. Yeah, alternate constructors, just class methods. What a stupid language. No, so you can't do this. Let's do this. But wait, this method has I don't know, there's no presence of methods here, I think, yeah, so I think it should work. This should work. So yeah, now it just says that you need layers, and then you need k-train, and then you need, oh, so it does know this test low and k test high. Okay, test high. Of course. Slovenia and Macedonia is very small countries, but we do our best. Accessing init on an instance is unsound, since instance name could be incompatible subclass. MyPy doesn't allow you to do that. Instance.init could be from incompatible subclass. Yeah, so you can, oh yeah, from module. Or you can, oh no, but Python doesn't have. Wow, okay, nice. So what are these class here? What has alternate constructors from a class method? So if you have like a class method, you can just like just a static method essentially, right? You're returning the class, you're returning self of this, and then you're just doing this. Huh, nice. Okay, class method, and then you are having, let's say, from layers, and you are supplying all this stuff. No, from layers doesn't have to. How do I want to do this? How do I want to... It doesn't, or maybe just check for dimensions here, having layers, and then. But I don't. I want to be clean. I want to make it very clean. From layers. No, from layers doesn't make sense. From dimensions it makes more sense, because this is, yeah, so like this is okay. So this is this makes more sense. From dimensions, and you can just generate this, or you can do this, which is simpler. Just tell me what are the layers and tell me what are the training iterations. And now, since I have to write this, I have to comment this as well, but okay, we'll see this. Now you are just here returning self, and you're returning layers k test k train k test low k test high. Okay, cool. Okay, that's it. Since you have this initialization method and this method, okay. You can't call super init here. Yes, of course you cannot call here, but you needed to call it here. Of course, these functions. Oh, these functions. Why did I do this? Dimensions. I have to think here. Self dimensions. No, dimensions should not be saved here. Why should it be saved? Since each layer you can access each dimension in each layer. Yeah, that for sure should be saved. Do I want to do this? Dimensions, then k-train, then this. Dimensions and layers. We're talking too much. Okay, so how do I, this should be the constructor. This should be the constructor. And this should only like, yeah, I don't need to save any of this. I don't need to save any of this since yeah, now the logs and the epoch strain will be in the main constructor, of course, but I don't need, I won't have logs for now. To do logs boss to do logs yeah, I have met several great programs for yet population. I do not understand how these statistics can square the previous and want to rise. Yeah, there are a lot of smart people, and a lot of smart people everywhere in the world. So not just in our countries. Yeah, Cloud Sonnet. Cloud Sonnet. Yeah, they're all nice. They're all nice things, but we choose to. Some people want to code in Emacs. Some people want to code in Vim. Some people want to code in VS Code. I don't usually code in VS Code. My primary job is coding in Visual Studio, since VS Code doesn't support C++ project solutions. So you have to have CMake files, and CMake files are bad, and they're all kinds of horror, and yeah, so it's very it's all over the place. But I code in everything that I sometimes code in Nano as well. So it just depends on I don't have any preferred things. Dimensions. Okay, so we have the dimensions. This is what we are using here on the this. Then I'm just doing this self dimensions. Why does this doesn't want to do? Okay, cool. Yeah, it should work. Non-dimension. Oh, here no. What we're doing is this is dimensions. This is len of dimensions. but line of dimensions will have, so what I'm expecting here is list of the vector dimensions that each layer should have. But I want to collaborate a little bit here. The list of the dimensions should follow the following structure. Dimensions is input layer, recurrent layer, multiple recurrent layers, and then output layer. Okay, so let's just do this. Okay, and then what we're doing is, okay, since this is what we call here, self cannot have not, so this needs to be or none. Since input and output layers have to, okay, input and output layers, just what are these? These are non things. These are non, because since this is the case, what I will assume that, okay, so I will assume that this is the case, and since I assume that this is the case, I have to add a non here, and dimensions e minus, oh no, the input and output have all have dimensions, so these are not non, but layers are non. So yeah, so this works. -1. Okay, cool. Self, this, it creates the self, it initializes the layers, it has epoch trained 0. I don't know if I actually followed epoch trained. No, I did not follow epoch trained, which means that there's no need for this, because testing suite follows this. Okay. Now create initial activations are just you're creating activations here. You're creating a vector embeddings. But since vector embeddings rely on the dimensions of each individual layer, you have to access each individual layer. So you're accessing this by saying layers I, and then you're accessing what does a layer I have. Since layer I can be non, can be also non, I have to tell my Py to never been. Oh, how do you tell my Py that it's this? No, this. Let's assume that my Py knows this stuff. So if knows this stuff, then what is the parameter here? The parameter is HH. Oh no. Further is the parameter. Then there's like a biasing function, and a biasing function in the network RC. So RC. Should we save this? Just for stuff we can, instead of looking at these, we can just save this here, and we can say this. Oh my god, C++ programming. Okay, so let's do this, and then now you can access these RC features, and you won't need to know, since RC features have these vectors, it won't just need to know this. Okay, cool. Okay, range. Oh, I see. Now the activations are in this range. Oh, I see. But because this is... let's add device. And let's add this. Okay, and now since we have this since we have this self.device, okay, this looks good. Now the thing is that this could be a layer that has RC features, but it could not be a layer. It could be just none. Instead of none, can we have a wrapper that replicates this thing here? Maybe we can have a wrapper. So instead of a recurrent neural network, can we have an interface that implements the recurrent neural network things, but essentially having just it being just a wrapper for nothing. Here. Layers. We're assuming that layers starts with dimension 0. And at the end, we also assume that we want to append dimensions -1 also. And now we have this is as an int, but instead of an int, I want this to be a type of recurrent neural network, recurrent neural layer, just so my Py doesn't do it. But I'm doing an interface of the recurrent layer. Like this, and so I can just do this. I can just test since I'm doing initialization of the functions. Is that too much to test? No, because I don't know. Hello. What are you doing? I am coding library for the forward algorithm. So it's a library where you where it implements the forward algorithm, and it's a algorithm. Let me just. Can we get more light? Okay, cool. It's a library that implements the forward algorithm, which is a different type of algorithm for teaching neural networks. There is in the description GitHub /FF. It's a library that just implements the forward algorithm in a way that is understandable and standardized. So I want to standardize things here, because many people implemented, but they just implemented in some Jupyter notebooks and left and right. This is essentially just taking all of these things and taking my implementation of the FFRNN and putting this into a piece of library that anyone can use. But it's more just a relaxing recreational coding session, since this is more of a test stream, because I want next stream to be coding in C++, something that is more interesting. So something like a what do I want to implement? Yeah, I'm implementing a node editor, so I would want to work on that node editor actually. So the node editor is just essentially like Blender, what you have in Blender, where you have nodes and this is but this is in C++. What I'm working on the node editor is C++. And I'm actually maintaining a rendering engine which is based on direct 2D. But I would like to move that rendering engine on OpenGL. So yeah, that's going to be quite some work, but the API is very stable and very nicely done. So it should be very interesting work to move that rendering engine to OpenGL. to make it like incredibly fast, because now like there's many calls, drawing calls, and since we have many drawing calls, it's too slow. It just renders very slowly. But in OpenGL there will be like just filling up some vertex buffers and some other buffers what we need, right? And just calling some shader, just calling a draw call and rendering everything on that. But that's for another stream. Probably these days. I would like to have a stream like that. So okay. Okay, so we did this. Okay, now that the layers here, each layer is of this type, of this FFRNN type. But since you see this is like functional programming, and I mean, I like functional programming, but in Python it's just so can I say like this? Can I say what I really want is I just want this. If self dot layers dot I is of type how instance is instance, and then you're doing is instance, and then you're doing FFRNN, else self dot layers I like this. But since this is functional programming, format. You see, it formats it really stupidly. Is there a way, I wonder, to make it like functional programming, but still like maintain like better formatting thing? As it's like item here of this or this has no attribute RC, and then MyPy doesn't know that you're testing here for FFRNN, recurrent layer. Because union types. Now if I need to implement an interface where I take features, or do I just implement a wrapper on the layer? Oh no, let's do an interface. Let's do an interface. An interface of this layer. Interfaces. Do I have an interface here? No, I don't have an interface here. Let's do this. IFF recurrent layer dot py, and it will just implement an interface which will do the following. Just have a abstract method, and it will do get dimensions. It will return an int, and now this is pass. Can I do pass? Why can't I do pass? Why? Oh, I have to just specify self. I think you can do pass. Yeah, of course you can do pass. Do I need to do like ABC that is just an app helper class and starting by ABC inheritance? Oh, I have to do this. Okay. yeah, I forgot about that. So now the recurrent layer can implement FF recurrent layer and module. Oh, okay, I see something else. Because FF recurrent layer doesn't have a forward. Oof, I see. It's all like stuff here. FFLib, interfaces, FF import, FF recurrent. So I have a recurrent layer. And then now, like, just but what does IFF implement? Get layer count? No, this is the, oh no, this is the network implementation. This is the network. Linear doesn't even implement anything, so linear doesn't even, it's purely linear without any interfacing whatsoever. So yeah, so I get it, I get it. I mean, I get it. Without any interfacing whatsoever. Recurrent layer, shit, okay. Since we don't have interfacing here, here there should be interface. So layers and maybe just recurrent layer I define like another, no, I don't want this. Recurrent layer is under a module. Interface of the recurrent layer. Can we implement recurrent layer under a module? And this way from torch and then into module, and this way we have the modules as well. Since module is very lightweight, then there's no need to implement anything, right? I'm working currently on FFLib, which is a project again maintaining like the forward algorithm. It's like we're implementing it inside library. And there are two different, for now, maybe it's good to just write here something. There are now two implementations of the forward there's like two different networks of the forward algorithm. If you go FF and then here there's like FFnet and there's FFC, but now I'm working on FFRNN with the recurrent neural network. And this is, I already have it implemented, but I implemented it very badly a year ago, so I'm now just reworking the implementation. And since everything is just it's just our own implementation, there's no standardization, so I'm doing much more work here to standardize things. Okay, so since IFFRNN will include module, I can just go here and I can say, okay, this is I don't even need instance, but I will just go and say get dimensions. Now get dimension, okay, so instead of here I will have this. and I will do from fflib.end.ff.net.interfaces.ff recurrent neural net ff current layer. So this is an interface to the recurrent layer, which is now accepting all this layer is accepting these interfaces. And here we are also accepting the again, this layer will be also accepting these interfaces, but also there should be a dummy recurrent layer, maybe in the interface here, maybe it's easier to implement. So this is ff recurrent layer. Oh no, here is better, I think. Def ff recurrent layer dummy, and this again just does this, and on the init call it just takes one value, which is dimensions, the dimension. Okay, dimensions, is it plural or is it okay? So it doesn't matter. So you're just doing this, and then I think by default I'm not sure. Let me just see. Self.rc features is dimensions, and since recurrent layer, I don't know how to tell recurrent layer that it has RC features, but okay, we have a getter, so it doesn't matter. What I'm curious is something else. So if I go something init, yeah, so init classes, because they don't return anything by default, like in Python, I don't think init class can return anything. So you don't need to do this. So that's cool. Okay, so this is a dummy layer, and a dummy layer will be constructed in the FFRNN here. So this is okay, let's just ff recurrent imports, just go to the imports, and we import here ff recurrent layer dummy, go layers append. Okay, here, and we go ff recurrent layer dummy. Oh yeah, of course we need to. Oh, well, huh, okay, whatever. Here we're just gonna have this. Cool. Now this should be gone, and this should also be like that. Okay, this should be done. Now here I can actually access get dimensions. So let me just format the document. So I can actually access these get dimensions, and also I can do this for that as well. Now the length of these dimensions is just, oh, I don't like this, I want this format document. Okay, now since dimensions is only here visible, instead of length dimensions, what about layers? And since all of these layers, we're gonna have to, oh, okay, well, wait, since we are initializing a tensor for all of these dimensions, Okay, let's see. I'll think about this if we actually need this kind of tensor here initialized. The activation functions may not need this tensor initialized. Since you already have a tensor. Okay. torch.nn why torch nn is not defined? No, it should be defined. Okay. Now loggers we won't be connecting loggers right now. What else do we want? What else do we want? Okay, set up the activations and the image input. Activations. This is the same thing here. You're setting up activations. Yeah, I'm gonna delete loggers for now because loggers is something that I don't want to include right now. But I want to include it later. Yeah, I want to include it later, so and this is also logs. Loggers. Yeah, loggers will be done with some callbacks probably. Oh no, maybe abstract class, just an abstract class, and then just you call the abstract classes. You call like some functions on the class. We'll see. Okay, let's see. Dimensions. So this is layers again. Layers.get dimensions. But I don't know why do we actually need this kind of function right now. Oh, I'm not sure. Torch, and then activation 0 is X from device, and activations -1 is Y to device. Yeah, so you're essentially doing again this. Okay. Push one forward pass is just going through these activations, and you're pushing one forward. You're pushing through each of these layers. You're pushing once through the forward and detaching them. I'm completely, this is completely different now. No, I mean, no, this is not completely different. This is the layer, and I'm pushing it through the layer. Okay, so activation at I, activation at I. Okay, cool. But the layer itself, we said it will accept the forward now. It will accept 3 tensors instead of a list of tensors. So the thing here is that this is not like that now. And there's no way, because Python is stupid. I mean, there's no way to overload these functions. So it has to be done like this. There is a way there is a way to say forward list then do this, and then say that this is a list of torch tensors and this is like an ID, and then do a return self dot forward, and then there's like x index minus 1, x index, and x index plus 1. And then instead of here it's like just forward list, but then you have to know the index of this. Oh, now that this doesn't implement. No, why? Tensor is not called. Forward list is not implemented inside the recurrent layer. The IF. No, I don't like this. I just don't like this. Because this has to be inside the interface. Forward layer. Yeah, this is much better maybe. And then here self list of torch tensors, and index is int. Okay, and do this. Okay. So now you are saying, or no, you're just saying an int. Yeah, you're giving this, and then instead of self.forward, you're doing self.layer set I dot forward this stuff. And here what you can do is just self dot wait, I just realized something. No, self dot forward says this is the index of the layer. We know that this is the index of the layer. We know that self dot forward accepts activations, and this tensor is not callable. Okay, let me just return torch tensor. Self is not callable. What? Self is frnn. Tensor is not callable. It returns tensor or module. Operator. What operator do you mean? Right. Self dot forward. Is it a other function? No, it's not other function. Oh, of course, activations, but activations at I probably, right? No, activations is activations. This is just activations. But what is activations? List of tensors. List of tensors, yes, that's it. Tensor is not callable. Why is not callable? What is not callable here? What are we talking about? Not callable. Forward list? Weird. Wait. Activations at I. Self dot forward. Oh, forward layer, not list. What am I doing? Of course. Okay. Forward list. This is correct. And now we are doing here test and new activations, and we are having new activations again. Here where we are doing this is self.forward layer, and then we're doing this again, new activations, and then goodness is list tensor goodness append. Oh, now here we're calculating this kind of goodness. Yo, I see. Oh, instead of the forward we want actually goodness here, because goodness also computes. Yeah, goodness also computes something here. I mean, computes goodness and the change in the vector, the new vector. So we need to implement this as an abstract method here. Yeah, this we need to implement as an abstract method, or not an abstract method. No, not an abstract method, because I don't think we can. Maybe, but I don't know. Yeah, here let's see. So let's say like I pass this, right? And now let's say I import torch, and from typing import callable tuple. Also, this should be it, right? So now I have this goodness, right? So if I don't tell it as an abstract method, it will what? Missing return statement. It's meant to be abstract, use ABC abstract method. So you have to tell it it's an abstract method. But since this is an abstract method, okay, I have to go into the recurrent layer. Okay, this implements this method completely correctly, but this doesn't. So I have to say goodness, and I have to implement the whole method. Like, just implement the whole method and say return self dot, and there's no way to return anything. No, there is a way. Just return x rec and x rec again. Just doesn't matter what you return. This function will never be called on a dummy layer. Yeah. So since this function can be called now goodness, this function returns a tuple. Oh, and now maybe this is better to be goodness of layer and return a tuple of two torch tensors. And here, since this is renamed, you want to return a tuple here, and since you return a tuple, you have to look at this method here. and say, okay, this method returns G and Y, goodness and Y. So let's just go into here and do this, and returns. Here we write returns first element being the goodness, second the output of the layer. The output of the layer. And now this is tensor representing the data coming from the previous layer. Tensor representing the data coming from the same layer on the previous at the previous time, coming from the next layer, time t minus 1. It's better to just say time t minus 1 for all of these, so there's no discrepancy. Logic defaults to lambda x torch. Okay, this is, yes, this is correct, but just logistic function to decide whether the data is positive or negative, and then there's like should we invert the output? False to false. Should we invert not the output, but should we invert I have to see this. Goodness, the goodness function is what? The goodness function is, okay, should makes inference on the recurrent layer and returns the new output along with the goodness of the input. Output along with the goodness of the given input. Return, okay, so we know that returns yg. Okay, we want here the goodness function. When it returns, it has to be, so since this is only activation functions, we are only looking at this output. Yeah, but now here we're not only looking at this. We want the activations to be, maybe what we want is, oh, I don't know what we want. Yeah, not the clone. You see now here we clone this function, this activation. Oh, this is so complicated. I mean, it's stupidly activate. What if we want to have what if we do a tuple here? Then if we do a tuple, here there's no way to inject this activation and goodness. Okay, so here's the thing. G and Y are these, right? And then we do G, then we do Y detach, and G is the goodness, right? So since we already have this goodness function here, computing this goodness function, can we do just computation of this goodness function inside this guy here? If this is greater than this, we already have some goodness thing here. These loggings, I'll just delete these loggings for now. I'll implement them later again. Oh, this goodness here is implemented inside the network as well. And predict and batch normalization and other stuff is implemented inside the network, which is not how it's supposed to be. Okay, there's a lot of work here. There's a lot of work. Maybe not for one stream. We're streaming already, what, 2 hours? Wow, that's a lot of work. What can we do? Wow. Yeah, but let's do it. Let's create this. Okay, so this guy here, when we get the goodness level, when we get the Y, we detach it, and we test if this is inside the guy here. And if it's inside the guy, we append. Well, the goodness, shouldn't it be here? Says we're returning the goodness. Why is this here? What's the behind this idea? FFRN and FF recurrent. Let's open up this guy here. FF recurrent. Let's just see here. Since this is everything was already put in here, so the goodness function, what? Okay, what this is called the forward, right? So the forward pass, it is from here. Why am I resetting here this guy? Yeah, this is when you don't have like unit tests and other stuff. You just reset something that they are not supposed to. This guy has to live here. But also, like the goodness function itself is not actually like there's no need to be a list of tensors unless we just make a cat and mean them, like concatenate them and mean the tensors. We need to take a look at what dimensions we have here essentially, but I think, okay, so activations functions, okay, so each activations have what they have here is the following. Okay, the activations have dimension of 1 and dimension of the layer. Maybe this is why slow. No, this is dimension the 1. Shouldn't this be, how do you call this function? You're calling x here, and then since len of x is this guy, here you're also doing 1. Well, okay, we'll see. I don't think this is 1. I think this should be batch size. Oh, but what does it accept? Tensor, right? This is just tensor. This is not zeros. You're just opening a tensor structure, which is not the same as doing torch zeros here. Oh, this is it. Wait. Okay, so we have to Python. Let's import torch. So let's see, torch.tensor torch.tensor 110 is what? It's a random tensor of size, shape is 110. So it is so it's not zeros, but it's a random tensor. Okay, so you're initializing the tensor, but why of this size, right? You're saying activations of this size, but why not the batch size? Where was I taking into account batch sizing here? This is why I don't this code was written 1 or 2 years ago, so I don't quite even, no, maybe 2 years ago was this, so I don't quite remember what the hell I done here. So I'm preparing this batch, and then what I'm doing is I'm seeing the goodness. So calculating, yeah, so goodness, you're calling goodness again on x, and then you're labeling all of the inputs. You're adding zeros, which is correct, and this is again unchanged. You're pushing to the forward here, unchanged vector of x. So this is, so x here is of batch size and something else, so like flatten, whatever. And then flatten, and then you having these vectors x, you are forwarding through the layer activations. Oh, because the forwarding creates a new vector, you don't even care about the initial activations here, do you? Do you care? Well, you kind of care, right? when forward is in the thing here, right? So when you get forward here, you just clone these activations, and then you do care about their dimensionality. I'm not sure how this worked here, because having one dimension here and now just all of a sudden having like, I don't know if PyTorch just like, well, what would PyTorch do here in this case? Not sure. You know, what if I have like, okay, so let's say I have let's say A is a tensor of size 110, right? So let's say 110 is A. What I want to do is I want to multiply this tensor with torch dot. So I want B is no, it will check dimensions. So is it possible to weird. Absolutely weird. How did I have one here? So dimensions. Oh, what if prepare badge wasn't a badge, but no, it is. It has to be. This function has to be a badge. Yeah, so yeah, your test loading and then so that. Not sure how this works here with the one and dimension size. So if I do this, B is like 8 times torch tensor at like 10 and then 10 and then 20, let's say. The size of tensor must match the no, B is torch mm A and torch tensor 1020. Opa. Yeah, that's what's supposed to be. Wait, A, why say 0? So what? How is A 0 now? How was... What the... Wait, what? Oh, wait. What? No way. I don't understand this. Wait a minute. How was it that import torch, right? And then torch dot tensor 110. You had actually some, okay, minus 30 something, okay, whatever. You had something, right? And then you do C equals torch tensor tensor 10 this, and then you're doing C, and then okay. But these are not random values, right? You cannot have random wait. Torch tensor constructor. Oh, wait. It's an alias for default type. There is multidimensional matrix. Then, what is is this alias? Torch tensor. Yeah, now torch.tensor and torch.tensor are different. Believe it or not. It's a class, and then there are few main ways to create a tensor depending on use torch tensor, use specific to create a tensor the same size or similar types or similar tensor alike, to create a tensor with similar type but different size in another tensor, create new. This is a legacy constructor. There's a legacy constructor torch.tensor whose use is discouraged. Okay, but why I don't understand self.data. This constructor is deprecated. We recommend using torch.tensor instead. What this constructor, this depends on type of data. If data is a tensor, it turns, unlike torch.tensor, this tracks autograd and will propagate gradients to the original tensor. If data is a sequence or not sequence, create a tensor. So it has to, we have to be careful about these things, because this kind of thing. Okay, for now I'm gonna leave this because I know that this works for some reason, right? But afterwards we're gonna test it out, why this works and why this doesn't work, since I have no clue really how on this. But okay, whatever. Okay, so this is now that we have the goodness function here, there's no need of this, but there's just a need of, like, okay, we have the layers of these layers, and since if this is bigger than flow, we want to append the goodness of G, and since we have all of these goodnesses append, we just do torch cat goodness and do mean on the first dimension. The concatenation will get us, this will get us what will get us this concatenation here? On what dimension? We need dimension 1. And now this will get us batch.size, iterations times layers, and then whatever the goodness function is inside. And since we're doing mean at this size here, and then there will be like only batch size and 1. Cool. Since we're demolishing this dimension by meaning them. Okay, cool. Okay. Goodness is per label goodness. This is a prop. We already have a prop. predict since FFnet supported IFF and FFC supported IFF, FFRNN should support IFF as well. So FF recurrent neural network should actually get an IFF thing here, and this should be from FFLib.nn interface interfaces import interfaces dot this way. Yeah, the net supports IFF and module, and this RNN should support FFN module as well. No, the recurrent neural network doesn't support. Oh no, not this, not this. This supports ABC and this here. No, not the recurrent neural network, but this guy here. The FFRNN should support IFF, and IFF has two things here: run train and get layer count. Get layer count is just simple function to get the layer count. So this is just simple function that we need to implement, and just cell.len.cell.len. I don't know if I need -2 essentially. Maybe -2 just to, I don't know. I'm not sure. I'm not sure even this function. Let me just get this function. IFF test suite. Yeah, it kind of just only hidden layers. Yeah, I could just do this. I could in the in the IFF I could just make return number of hidden layers in the network, number of hidden layers. Okay, since we get this, okay, since we have this, we need to run train. These networks are different from the original neural networks that we're training, so these are a little bit complicated to train. That's why it's just yeah. So we already have something like run train, right? But it accepts a batch function. Accepts a batch. Instead, the interface wants to have this kind of idea, this kind of signature. So, okay. Preparing the batch doesn't. Yeah. Okay. Let's see about this. We already have positive and negative things right here. So hpos and hpneg is just, we're gonna just do this. No, this will be maybe xp, but xp is create initial activations is just like activation, so this could be just h. Set the input to the positive and negative data. Yeah, so this positive 0 is x positive. Oh, what does that mean? Yeah. Oh shit. Yeah, you know what? Train doesn't accept here. Wait. This guy here negative and positive data, but it had the classifier as predicting the input and output. Since IFF thinks that you're going to combine the input and output, and IFF doesn't expect the input and output, it expects them to be combined. And since it expects them to be combined, there's no way to uncombine these things. But FFRNN expects them to be uncombined because there's no need to combine them at all. So to implement IFF interface is a bit different. It's a bit different. But why implementing IFF interface? We're not just saying that we don't implement IFF at all. Yeah. Oh, can we? If we don't implement IFF, can we implement then the suite, the FF suite, which implements IFF suite? Yeah, this is like a little bit of problem because IFF suite implements FFnet as an IFF. And if you're not implementing IFF, then there's no. Well, you could do this maybe you could just do, okay, you could just say that there is run train, and this is like, I don't know, combined, and then you call run train, which is not combined data, which has different kind of signature, right? Which is essentially yeah, here we're running a train with the combined data and then running a classifier with uncombined data, which is different. This way, what does this have access to? FF suite, essentially what does it do? It essentially encodes, yeah, you're implementing these kind of whatever traits, like things like functions, and then you're saying, okay, I want to combine, encode, to combine, generate negative, blah blah blah, and you're pushing on train, and the net doesn't quite care about these things. You're either way going to write this interface, this implementation. Yeah. Run train epoch is just calling it inside class. These two things could be moved to be inside the IFF suite, and then essentially you're overloading this save method. Just something. Time to train and time accuracy could be inside. Why aren't these inside? My question. Is it possible to, like, IFF suite implements I mean, it has train as an abstract method, right? Must be implemented by the derived class. Yeah, this implements the train and this method, but if I have, yeah. Yeah. Okay. So what I will do is this. I will move these two functions inside here, right? And then I will do this here, right? So now when we define train, we run it for this. Now this is already in self, measure time, and we have time to train, right? Time to train will be already defined in the input, which is default memory value. Time to train is just an int or a float, rather, maybe. Okay, now dev test is just running a test epoch on this self.loader. Oh, the self.loader maybe doesn't exist. No, it exists. It exists inside, yeah. So this is the testing method that we want. So we have already put it here. Okay. And now this guy is just, I mean, this women or whatever. Happy International Women's Day. Test accuracy and test. Oh, train time to train. Let's do self test accuracy, again float. Okay, now that we have all of these, we can do here test. There's no need to update, so there's no need to extend the dictionary. This is already cool. Cell.net.train. Yeah, now since IFF self.net is an FFnet. It's an IFF. Oof. Yeah, we'll have to change this. Since there's no way. So this is cool. Like, you just implement two functions, and you can train your network. This is cool. It's really cool. And we'll implement the same class for FFRNN. But what I will first do is this. Okay, let me just close this. What? Okay, let's just do this. Okay, first this, we don't need that. First, like this. Okay. I need to implement change this module first before we go to the recurrent neural network. So what I will do is I'll go to a new branch and I will say RNN, right? And on that branch I will implement recurrent neural network, this. Okay, so this is on that branch, and I will say implemented FFRNN. But that branch, okay, we don't now in the main branch. I just want to first to change the suite here. Yeah. Why this logger? What is this logger? FF logger. Do we have logger here? Oh yeah. Oh, okay. This is the. So okay. Now FF train. we'll accept this. We'll accept x positive. Oh, we have x positive, y negative, y positive, x positive, and y negative. Yeah, x positive is a tensor, then y positive is again a tensor. There's no here there's no ChatGPT and there's no Rust. No, we are going to be programming maybe in Rust just to check it out, maybe someday later. But no, first we C++. We're gonna be programming. I don't know, tomorrow, maybe tomorrow again, daily stream probably, coding again, maybe FFLib, or maybe just doing the notator and the notator or the rendering engine. But I would like the notator to like just work on the notator. It will be fun. It will be fun. It will be fun. Okay. So since this is positive and this is well, so y x positive, y positive, x negative, y positive, y negative, all of these tensors. Nice. Also, this is an abstract method. And then there's this idea. But combined is like if the network supports this or if the network supports this. We don't know. We can't say. Some networks want to combine them, some networks don't combine. But should throw probably if something is not implemented, just throw not implement, something like this, just simple. Okay, since this is the implementation of the net of this, we are going to be doing combined here, combined. And now the FFnet doesn't have combined, so this implement train, but not combined. And here's the thing: you have to implement run train, but there's no way to. It's not made to tell. So there's like export. So implement all of these things here from the train module. FFnet RFF, yeah, round train. Okay, so we will implement this, but there's no way to tell actually. Just don't do this, right? So there's like just arrays not implemented. Do you erase not implemented, or do you erase a val? What kind of error do you erase? Type, import, lookup, syntax, system, runtime, timecode, overflow. Oh, there are nice errors here. Unicode, decode, module not found, not implemented error. And then you come base for all not implemented error, and then you maybe put use run train combined with conjunction off, or what? How does it say? With conjunction how are you supposed to say? Use run train combined with conjunction of. With conjunction off, is it? English is not my native. With conjunction of. With conjunction of something like this. How are you supposed? Definition of conjunction with. Of conjunction with. No. no, conjunction is just use train in conjunction with in conjunction with the combine. There is this idea here, there is this combine to input with and what is the data loader? Data processor has this method here, combine to input. Yes. So what is this? Use data processors combine to input method. Use run train combined in conjunction with the data processors combined input method. Yes. Okay. Since this is correct, also this has to be correct, and we have to run the test and see if we have broken something, but I don't think we had broken. So combined, and we need to just also implement this kind of this again. Just say that this is not implemented. Now that we have this implemented, the run.train is missing. Oh, run.train combined. Now we just, because we are doing this. Also in the FF suite is, we're already calling this. Okay, so we can just run black to format it, to format all this. Okay, all done. Yes, just quickly formatting. And what I want is just first to run. You see, I don't have tests for this. I will run just PyTest just to see that what tests I have passed. But I don't have tests for the FF suites. So that's something that I have to do. I have to create tests for the FF suites. Oh, we fail. Yeah, nice that we detect that test fail, but they fail because we're just calling run train instead of run train combined probably, and this is probably the only test that will fail. Why? Okay, yeah, passes. Now we'll want to add also, yeah, this interface is now implemented in this, but also we just want to run these things to see if they all work. Or maybe just while we are here, we can do some unit tests on the things, but I want to just to try them out to be sure that they work. Just manually try them out. Just 2 iterations, 1 iteration here, 1 iteration here, just manually trying them out. I mean, it doesn't take too much time to do 1 iteration of training. Yeah, it works. It should test them completely fine. Yeah, yeah, we can do this as a test as well, with just like 1 iteration here, and run it in PyTest. But instead of MNIST, we could do some other smaller data set just to see if that works. Okay, so that should be fine. That should be fine. Another thing is like we have to check now MyPy and we have to do it in strict mode. And if this works, we can finally push, and I will show you guys how on GitHub everything is checked thoroughly again. But since MyPy is just MyPy will say something if it's not okay. But the whole problem, MyPy is too slow. It's too slow. When your coding is slow, and I would like to have like a faster version of MyPy or something, like, because PyTorch is really huge dependencies. Probably takes a lot of time to index stuff, and I don't quite like it, you know. Yeah, no issues found. Okay, no issues found. So I can push I can push to the to GitHub to see if everything works correctly. So first we added the run train. This we add, we added this interface. We said here not implemented. We said this is not implemented. We cleared up this and we put it here, we put it here. Then there's this, we added this idea. Oh, you see a bug where like fork has fork is a great software, but here like you can see that because it starts here, it thinks that it starts a string, and it just renders this as a string here, not seeing that there is a string here ending. And yeah, this is the tests. So this is just implement separate methods for run train and run train combined in IFF. Also, we have to just say that we moved basic train and test method. This is from the FF suite we moved them, but from the FFC, what from the FFC do we have? Yeah, FFC already also. Yeah, but FFC will do this, validate self. What does it do? Yeah, validation, changes validation here. Yeah, FFC should contain, yeah, this maybe we can move it, and this also we can just, yeah, we can just do this. The train, let the train just be the train, but this is okay. So just do again black. Again, let's rerun again the FFC here just to be sure that the testing procedure will, the training and the testing procedure. Okay, so FFC, this could be moved without any problems. So move the test and the train and test methods from FS suite to IFF suite. Overload them if needed in other suites. Okay, yeah, it works. So, okay, we can discard that. We can push the commits, and now when we push to main, what we will see here is that, okay, we have pushed this commit, right? And you see that there are checks here, and it will run all of these checks. So it will just do setup Python, it will install Poetry, it will define some local environment, caching for Poetry. It will just take whatever is in the cache, because if we don't change dependencies, they can be taken from the cache and used again. So just optimizing stuff here. Installing project dependencies, we'll see that everything is installed in the cache, so we'll just skip that. Maybe, yeah, this will just run again, like installing project dependencies, just to check it out, but maybe we can just skip that from the, yeah, it's fast enough. And then run MyPy. MyPy is not fast enough, even on the GitHub servers. It's just slow. It's the slowest step, but there's nothing to do. Like, I've checked, like, there's something caching, but when caching is only for like incremental stuff, and this you're pushing on the main really not incremental things. So it essentially, again, it will have to check them all. It checks the black compiler, it's like running all the tests, and again just printing everything. And since everything went completely okay, it just passes the build checks. And this, it doesn't do a release on PyPy. If you want to do a release, you'll have to I will have to make a tag, and this tag will automatically spur up another workflow, which will just take the build stuff, the build artifacts from here, and it will publish them on PyPy, and it will make a GitHub release automatically. So it's pretty cool. That's pretty cool. Everything is automated. You just push, and that's it. You don't need to worry about anything. Now that we have this, I don't know if I want to continue on FFRNN work. Maybe I want to make just a couple of tests for this. Maybe just spurring up these instances here, FFC and FFnet, some simple instances of this kind of thing, but not the mnist. The mnist is too heavy. It's very heavy. I mean, it's not very heavy, it's heavy to test. There's maybe what we can do is, like, instead of, we just want to test if everything works right, so if there's no errors. That's the only thing I want to test. So mnist is not really I don't care if it's mnist or if it's something else. So maybe we can make just a simple generator that will generate some kind of simple structure. Yeah, like, is there a testing? Yeah, so let's do this. Let's go on main instead of FFRNN. Let's do this. Is there simple is there a simple data set for testing purposes, for PyTest testing purposes? Like, I want just a simple data set that will work. Oh, what I can do is I can generate points into 3D in like multi-dimensional space, and then I can just should we try that? How do you let's say you have some seed, right, and you generate some random points, right, and then you do some random like planes, and then you intersect these planes and points, and then you get a pretty good random set where all of these points are. And then of course you introduce some noise as well inside. It will be an interesting thing to try out visualizing this kind of stuff, like synthetically generated just toy data sets for PyTesting purposes, like small synthetic data set for PyTest. No, just this small static kaggle or something. But the problem is it's just like very dealing with very small data sets. It's just like, you see, it won't give you anything. It won't give you anything. But synthetically generated data sets that are easy enough to learn, it will give you exactly what you need. So CFakes, real and AI generated synthetic images, synthetic layered images, simulation, synthetic faces. So wait. Can we play around a little bit with Manim? A little bit. I want to play around with Manim. I want to play out with Manim, but maybe this it's like I'm 3 hours streaming, so it's just not fair to play out now with Manim. Just writing a couple of more tests, and okay, so let's move this. Let's implement it RNN. Okay, let's say like this. Let's say this. For now, we're implementing FFRNN, but FFRNN is not implemented yet. If I push here, I will get a build failed, but I want to push that just to have that on the server for if someone wants to fork that, or just to have that on the server. Maybe just implementing work in progress. Yeah. Okay, this is kind of implemented. This is not implemented fully. This has to be changed here, but also what it has to be changed is it has to be added an example that uses FFRNN. And maybe tomorrow I'll do that, because I'm really tired right now. I'll do FFRNN. Yeah. So okay, so I think it's fine for 3 hours stream. We kind of worked on everything. We changed the whole thing here. It's not a lot of code, it's not a lot of things, but it's fine. We implemented the other interfaces, and yeah, these other things we implemented. That's easy. I want to work a little bit more, but I have to rest. So yeah, that would be it for today. I'll just leave that here, and we'll do tomorrow. We'll do something more interesting, something with C++ probably. Yeah, I want with C++, but it's all development. It's all like it has to. You have to have you have to have time here, you know, because there's nothing. See, like here you just have to implement this kind of structure. Now I'm saying that this is it, but yeah, let's write 4 more lines of code, you know. Then you can just this is x negative, and this is y positive, and this is y negative, and then here you're just doing this, and then yourself that, and you're forwarding on the layer. You are doing forward why can't I access self? Goodness. Yeah. You're doing goodness layer. Oh, but do you need goodness? That's a trick here. Maybe this is just forward layer. Okay, let's say that this is just forward layer, so we don't need goodness here. Here we clone this new thing on the so we are doing for frames, for something frames. We don't check epochs here. We're doing for this kind of frames. Yeah, what is this now? This is for each layer, and we're training these on the positive and negative data. From what? Then you're forwarding them through this layer. Yeah, but now layers train definition is what? Layer trained oh no, not this. This train run train takes a list of x and y data, and it takes an index of that data. So if I go back into RNN and you do run train, you have to take an index of that data, right? But okay, let's assume that we don't have this, right? Let's assume that we don't have this either. Now, why does this make problem? HP positive? HP doesn't exist, yo. HP doesn't exist. H exists. I don't know what was HP. H is like this, but what is P? I don't know why I named this like that. Since like H are sometimes named like the activations, but P, why P? That layers. What is a layer here? Yeah, a layer is what? Is it a module? It's an IFF recurrent. Oh, IFF recurrent doesn't implement this. Okay, we need to implement this. So forward. Yeah, it implements forward. It's implementing forward, but it's not implementing run train. Yeah, run train. Def run train. Abstract method. Yeah. Yeah. Okay. So let's just do this run train. It implements this. Run train. It has. Okay. Let's set typing. Let's set list. Let's go back to run train. Implements this. It has to run train. Oh, it takes not X, it's an activation thing here. That is correct. That is correct here. It's an activation thing. What's up? What's up? Yeah, it's an activation thing. So there's no H. So, yeah. Activations are. We are doing activations as H. X means input. Y means output. H is something hidden, some activation, but it doesn't necessarily mean hidden. It just it can mean hidden or non-hidden. Like we don't care about that. We just care to have a nice naming convention. Okay, so another thing is we are doing this again here, but we're returning, well, since run train here by default will return none, right? Here by default should return none as well. Like just pass that, don't care. Run train on the other side here, it should return none. And where do you learn ML from, and what should be the prerequisite, a proper path to specialization, if you could tell? Yeah, that's a nice question. ML, I learned ML mostly on faculty, believe it or not. We had great subjects teaching us from creating really simple neural networks, because like my module was all AI. So the from simple neural networks, so perceptrons and simple things, to big massive convolutional and transformers and other things, and of course ML just as ML, and doesn't mean neural networks, it means also we've learned different kind of algorithms that like you will just you'll think they're too old, right? They're like nobody uses this shit, and nobody even now, like nowadays, just like LLM, put LLM, and that's it. But actually there's like surprisingly a lot of theory behind why do people thought like that. And of course there's a lot of mathematics as well, and people think that like yeah, I'll learn mathematics and I'll learn like just like how do I like how do these networks work or whatever. But actually I would argue that it's much more important to like learn like how to write some things and how like they work internally. And when you understand, like let's say PyTorch, some library, you'll understand like a lot of these architectures, how do they work. And then you'll automatically understand or can like really fast learn why in theory that is, right? Why do they want that? And maybe like my approach of parallel doing stuff like coding like non-stop, and like for every week we had some tasks to code, some things to do, and doing that just teaches you this other way of thinking, or this perspective of practicality instead of just theory. So do you use your system memory or shift to cloud for training those? For big models, I did have a nice enough GPU, not good enough, but I do have on this PC, I do have 32 gigs of RAM, but I also have this 2070 Super that has like 16 gigs of like shared memory, and you can train okay models, right? I mean, not good, not very big, but okay. Like 4070 with like 16 or 32 gigs, you can train pretty good models, pretty big models. But you're almost always for fun, you're almost you're training your own but small models, and for work you're training you're fine-tuning very big models. So there are these two things. Like if you want to train your own, I guess the subscriber yesterday and maybe left a message, come back and upload videos. Yeah, I saw that message. I said, yeah, that guy just automatically knew when I would upload new video. I have to see maybe more. Yeah, I would want to do more XCP actually, but since this is kind of a project that I'm doing for my master's thesis, and I want to document everything that I'm doing as like from scratch, because this is a type of algorithms, forward algorithm that is used to train neural networks on a totally different way. It trains them not using back propagation, but layer by layer, and it allows for things that normal neural networks don't allow for. And since this is pretty new stuff, and I thought that it could be cool just checking out how things are done in Python and learning, and I'm as well learning things, right? But like tomorrow I want to do a live stream where like I will do C++, but I will do production level C++, because my day job is actually just doing C++ in production, and I'm building a node editor, and I'm building a rendering engine. I'm maintaining a rendering engine, but I want to like move that rendering engine to OpenGL because it's now like direct 2D. And the node editor is also like a C++ based node editor that like calls DLL functions and does all kinds of interesting stuff. So there's a lot of stuff, and that's why like competitive programming doesn't pay me. So like I have to do some other stuff, and I have to do competitive programming as well. And yeah, so like there's I think there's so much to learn from production level, because I have done competitive programming for like a long time, and you always learn like new algorithms, new stuff, but you don't learn how like you should actually code software, because coding software you have to think about maintainability. You have to think about how this, like when you define a function here, and then like after like 5 days or whatever you want to add a parameter to this function, right? It's not as easy just adding a parameter. Okay, like you have to update documentation, you have to update what if other functions break, what if tests break, what if something else breaks. And now if you're like upstream developer, like if you're just doing if you're doing something that other projects depend on that, and you break something, you break some API, you break some call, you have to go and tell the other projects and go and fix stuff. And all of this stuff takes a lot more effort than just like, okay, yeah, let's put a perimeter here, and we'll hope we don't break stuff. And that's why I'm saying like all of these like YouTube like I was when I'm coding, sometimes I just put like some YouTube streamer just to like, and they talk about coding and they talk about, okay, do this and do this and do that and do that, but nobody just goes and show you how they do it, right? And when they go and show you and you see how much mistakes do they make, and like when like you will see in Rust when just like they're calling unwrap all the fucking time, right? Then why the fuck you programming in Rust, you know? Like if you're calling unwrap all the time, or you're just doing like unsafe, like what's the what's the point in programming in Rust then? Like why not C++ or C, you know? It's just the same. And when I will be programming here, of course I will make mistakes, but I want somebody in chat, okay, correct me something. Okay, let's say I make mistakes, something with callable here. Okay, let's somebody correct me, and we'll learn that that there's some other things that you can do. And like I've learned so much stuff other than like CP, that when I went for some interviews, let's say, that like they asked me stuff that like, okay, how does FFmpeg work, or how does like how can you do something like architecturally, like, right? And CP is just like, I know that's like you can just grind some lead code. Yeah, when we're here on CP, let's go on lead code and let's solve the daily challenge. We forgot about that. Let's solve the daily challenge. I'm solving just daily challenges because like just it's I mean, I wanted to make streak, right? But I forget. I don't have some kind of daily reminder to do that. I need to install daily reminder. And I started doing this in January, like just for New Year's like stuff, and like, okay, I'll just one task because I don't have time, but one task I can do it, right? So and then like you forget one day, and then you solve the next day, yes, but the streak is gone. And then you do this, and then I had like 14-day streak or something like that, and then I forgot the day. Yeah, it's so painful. Like it's so painful maintaining this streak. You're giving a string 0 index blocks, either white and black, representing the color of the white block. The characters denote the colors of white, black, repetitive. You're giving an integer k desired number of consecutive black blocks. Blocks in one operation. You can recolor a white block that becomes a black block. What minimum number of operations is? At least k occurrences. It is at least one occurrence of k consecutive blocks. Okay, just simple block, just simple. I will solve it in all n, because even though this allows, this is funny here. Let's just solve it all of n, because why not? Prefix. I don't like the lead code. I mean, lead code is great for interviews, I believe, because like I had some interviews just for Huawei or something like that. I wanted to do some internship, but I didn't went out. But like they gave actually lead code problem, and it was I solved them, but it's just just kind of, the problems are nice. I don't think it's but they're too easy. Even the medium problems are too easy, you know. And when you see like the problems like that, it's just I don't know. What is this? The node. What have occurrences of black blocks? I don't know. It's and the editor, it's stupid. The editor is stupid. Prefix minus k plus 1 if prefix of int sum is prefix of I plus, no, prefix of k minus 1. Let's just do this, k minus 1, then this minus prefix of minus if I minus k is bigger equal than 0. This is prefix of I minus k, otherwise 0. This is the sum, and then the sum is the black boxes. And then the k minus the sum is what is the minimum, so min minus k minus sum, and then you do minus is this, and then minus or something like that. And because it doesn't show you anything, like you see, like unidentifier, because k is big, the editor doesn't show you anything. Doesn't even know stupid stuff, like just I don't know, whatever, something stupid, doesn't know it. So I just go and I save all of the problems actually. I don't know, I like to be ordered, so I just save, I just have it's all on the GitHub. 2379, 2379, I forget things, 2379. Okay, just do this. No, I've seen people so good in competitive programming that like I'm just like, this is insanely they're insanely good, but also like I'm saying this is not something that important for companies. At least if I'm hiring people, I'm just like saying, yeah, how competitive, even if you don't know competitive programming, you know how to code, you know how to understand things, you want to learn, and that's the most important stuff. Because it's just that I just like daily challenges. I even do like Duolingo just to have fun daily, you know, some like just 2 minutes of coding. It's not that big. I haven't coded here on LeetCode. The problem is on LeetCode it's just very hard for me with time zones. It's just very late for me. It's like at 3 p.m. and even when I code it here, it's like I'm sleeping and I'm coding this. Yeah, of course. But no, even people on my level, on my level or on our level, it's just they're good. They're good people, and I believe that anyone can do it. It's not that problem. Okay, so let's just go here. Okay, yeah, and I don't like using ChatGPT. I just hate ChatGPT. It's just I don't like using it. I want to this is much nicer. This is much nicer. You go Stack Overflow, you see a beautiful answer, you understand that. I know the ChatGPT will give you the same answer, an even more beautiful answer, but I don't quite like it. I don't know why. It gives you stuff that sometimes are not correct, but also it gives you stuff that like that you're not supposed to do, or it doesn't understand your project that well. And that's why I prefer just to leave it without ChatGPT. Even if I'm making some dumb mistakes, I'm gonna learn this way more than doing with GPT. Yeah, so let's code a little bit more, but maybe no. We should. It's 3.5 hours. I have to eat a little bit. We have to make pause. tomorrow, if I have time, I will make a stream with C++ on the, maybe I could show you right now. I could show you just for those guys that are here and that are respecting my stream. I will show you something. Sometimes initial things are good by GPT, then functions. Yeah, that's correct. That's correct. You know that stuff with. I mean, what I don't like is like beginners using ChatGPT. If you're already like intermediate or advanced programmer that you know how stuff works, you can really easily tell what is garbage and what is not. But beginners cannot do that, and this is the whole problem. They use it all the time, and they cannot tell what is good and what is bad. And if you cannot tell it, and they go and they just are literally transcribing what ChatGPT does. Okay, so what I'm actually doing, I don't know how much I can, like. I mean, I can show you. I can show you some stuff. Because some things is public, some things is not. But okay, I want to show you some stuff. What I'm doing, actually, what I'm working on right now is rendering. I mean, not rendering engine. I've done that. Yeah, let me. Yeah, this the whole problem is compile time. In such big projects like C++, it's just the compile time is hilariously slow. The projects are really fast, but the compile time is slow. Oh, okay. Wait. I have to go and to take this off. Yeah, so now, okay, cool. So this is the software I'm working, this is a software that our laboratory is working on. I can show you because this is a promotion tool for the laboratory. But what we're doing is essentially like we're building a notator where like you can let's say import from JSON, and like I want to implement some other imports as well from some other formats, but we'll maybe together do it on stream. Like you can implement some graphs, right? And like you can set up some nodes, and each node is essentially it's like implements an interface. But there are two types of nodes. There are like auxiliary nodes and processing nodes, data processors. But there are other also, like I want to implement some other interfaces as well. But the whole idea is like you're implementing some interface in C++ in a DLL file, so outside the software itself, and then this motherfucker reads the interface, reads the inputs and outputs, like the DLL file registers them, and then like you're reading these inputs and outputs, and you're creating terminals for these nodes. What am I doing with the? You're creating terminals for these nodes, and like each terminal, like I'll maybe this is not a good example, but I'm working on it. But like each terminal can be like, for example, true and false. Right now here I will need to implement a checkbox terminal, but I have slider terminals. I have like, this is a slider terminal. Then there's like a constraint slider terminal where like you have a actual slider, well like from 0 to 1, let's say. If the DLL implements this, like this kind of input, then like the notator knows how to implement. The notator knows how to do this kind of how to show this kind of input on the screen. It's on the D2D, so direct to the renderer. And the renderer is like everything is like from scratch. Like everything is C++. Everything is like low level stuff. There's nothing I want to make the renderer actually in OpenGL. Just I mean, I have the interface of the renderer. I just want to implement an OpenGL implementation, and then like you can have like some other kinds of nodes, like a list node, and like you can add like strings to this. This is a string list node where like you can type some strings, right? Then there's like a generic inputs outputs node where like it's now laggy a little bit because I'm through a remote, but like you can implement, let's say, some, I don't know, some like object data. You can let's say an integer, whatever, time. You can implement, you can do some other stuff like arrays, JSON documents, strings, whatever string property, and then you can combine this inside this here. And after that, you can export that and run it from the CLI itself, like run the config file from the CLI itself and like do inputs and outputs on the, like do inputs on the CLI on the command line, and does it outputs as well. And like it gives you outputs, and then these outputs can be redirected on a JSON file that essentially like, and essentially you can just run it on some server. So if you have like some complicated graph, upload it on a server and run it on the server using the CLI. So like some application runs that on the server. So it's like really interesting thing. And I had an application, maybe I can show you that thing, that demo here, because this is kind of fun. And there's no Rust. No, I'm kidding. I'm not hating Rust. I like Rust, but I like the borrow checker. So no, I'm just having fun. So this guy here, this guy here, let me show you a cool standalone project that had this. So it could like yeah, like it's very interesting that like you can implement anything in a DLL file and then dynamically load it, and or hot reload it. So you have hot reloading in C++. And I need to implement that in the node editor, because like I have like there is implementation for the hot reloading on the extension on the node itself, but the terminals don't update. So I have to implement that. So the terminals should update as well. Yeah. So if you change like terminal, and what you can do, like instead of reloading the whole application, rebuilding the whole application, you're just rebuilding that particular node, that particular DLL file, and you're hot reloading that particular DLL file inside the node editor. And it's amazing. It's amazing. It's like the node editor is not more like than 5,000 lines of code or something like that. Everything probably in the rendering engine itself is like 1,000 lines of code, maybe. Maybe some, but it's not even 1,000. I mean, depends on what do you want, like, because there's safe objects and there's safe things like that. Would this work? Import. Yeah. Okay, cool. So like let's say like this. We have like standalone application where you are loading an image inside the node. You have some morphing operator where like you can change kernel size. And then you're having a color mix node, and you're mixing the original image with this image. But I can add like another, let's say, like here I have just implemented morph operator, just like this was just for showcase, but I can just like do this, and then like maybe I can just do another color mix node with the original image and this image, and then I can do this, and then I can like do this, and then I have a road, like I have different operators, different kernel sizes, blah 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 blah. Like I can just say that this operator looks interesting. Let's say this operator, I want this to be here. I want to mix it. And what is interesting is that maybe I mix this and this guy here as it was. But I don't know, like you do some stuff, I don't know, whatever. Just whatever. But what is interesting is that like on every like change, it calls like a callback function and it re-renders it recomputes the graph. And there's so much things that we can do. Like we can do lazy computations, which is not implemented inside. So like if node is already computed, like just don't compute that. You can do like maybe like invalidation, caching invalidations or something like that, or baking stuff inside. There's so much stuff to do inside, and the goal is at the end. What the fuck is this, a unique project everyone looking for? Yeah, maybe. I don't know. Yeah. Yeah. So in the end, it was the goal is like to make a node editor that is capable of reading ONNX files and like parsing them and like making a whole neural network inside the node editor. And then like you can just push like 3-5 buttons like and combine like a fucking neural network inside an node editor in C++. Man, like there's so much to do, so much stuff to implement. And like everything is vectorized, so like you can fucking zoom in here because like there's like the direct 2D, right? Everything is vectors, and yeah, like there are stuff like when it's out of the screen, like there's like camera cooling stuff, and the rendering engine is not much more than 1,000 lines of code. But but what I want to do is I want to make it in OpenGL, because the direct 2D is too slow. It's too slow, especially when you have too many objects and you have too many draw calls. Each draw call is very expensive, and there's no way. Like I took a look at like making groups, but even if you make groups of calls, like it's too expensive, and this is why I want to move on like not maybe OpenGL, or Direct 3D, maybe Direct 3D. Yeah, I don't know. We'll see. But with just a simple shader and simple like with the rendering engine, just move that in OpenGL, and that will be fine, I think. But yeah, essentially this, and it updates completely like everything in real time, and like each terminal implements an interface that essentially, like, these are like switcher terminals, drop down terminals. I'm not implementing drop down, just switch. These are like sliders. These are constraint sliders that like you're giving constraint objects, and then there's other terminals. So this is like a browser terminal, whatever, button terminal. What do I have? Yeah, checkbox I need to implement, and some other terminals. And textbox terminal. Actually, I don't have textbox terminal because implementing textbox terminal in pure C++ is a little bit painful, because there's no way, like you have to do some other stuff, like you have to. Is it lagging a bit, or is it just the stream? Yeah, it is lagging a bit. I mean, I'm dispatching, I think, the call, so, but it is lagging. Oh, the slider is lagging because I have it through the remote software, and this is rendering a 4K image. So yeah, 4K image is not good for Direct2D. yeah, if I do it in a smaller image, it will be not that laggy, I think. Okay, yeah, this is laggy because you have a dispatch at the image, so you have to process the image, I think, before you update it. I'm not sure how did I do that, because this is not multi-threaded. So you have to this is not meant, this is meant for more for geographical informational systems, because I work on that. It's meant for like you're doing a graph and you execute the graph with a button. So like because these graphs are huge, this is not a graph that you will execute every millisecond or something. But the whole rendering engine could be faster, could be way faster, because this is again direct to the, it's slow because of the draw calls here. Maybe I can optimize the draw calls. But we'll see. I'm not kind of sure. I tried some optimizations, but they didn't kind of work. But yeah, so there's a lot of stuff. There's a lot of stuff to show you guys, and yeah. But maybe this is enough for today. Just having this kind of yeah, we implemented this, and I'm going to push this branch here on the, wait, I will push this, but I will say that this is work in progress, because we have to finish this. We have to finish, like, this is fine, but here we have to finish this, because I don't know, I have to think about stuff here. So this is work in progress, but because this is work in progress, I will have to amend this commit, and I will have to push to origin. I will just, yeah, so RNN, I don't want to is it on the main? I don't know if the workflows are on the main or not. Yeah, so it's even here it has a workflow, but this workflow will fail, so I can just cancel this. I don't need to. This workflow will fail because nothing is known. Okay, cool. So this should be implement. This will be needed. Will be implement. I don't know if I want to show you guys like release, but no, now releasing. There's no point in releasing now, because we have changed so many stuff. Before we write documentation for this kind of stuff, we're not really, we after our FFRNN we will release 0.2 probably, because this changed so many critical stuff in the interfaces, so 0.2 will be fine to be released. Okay, but yeah, that's it. Love you guys. See you again. Probably I will hope tomorrow. If I don't have something else pop up, I will hope that I can see you tomorrow building actually C++ stuff, not this Python. But I have to do I have to do even Python as well. Maybe not tomorrow, because this is my master's thesis, so I have to work on that regardless. So even off stream, I do work on that. Yeah, thank you guys so much for watching, and I just keep grinding, and I'll